All right. Well, now that I realize that I'm next, so Jason, some of you may have noticed that I tried to interfere with Joseph there initially. So I guess I'm on, right? Yeah, there we go. All right. Well, I decided to just throw a little different flavor into these presentations today. Everybody's been talking severe weather, so I thought I'd switch gears. So we're going to talk a little bit about snow, and our snow season actually is not far away for some of us. So,
that's the guy with the hula shirt talking.
Get out of here.
see, I got to have the positive spirit. All right, well, first off, I want to just thank my guys back in the back from the University of Wyoming, Bob Capella, and then there's Ethan Collins. These guys are in joint forces with our office on the C-STAR project. Basically, they're the runners of this event, or this whole project. And it all kind of started with us about 3 years ago. We started talking in our office about how can we improve forecasting in the Rockies. And the Rockies, as you know, is a fun place to forecast if you've ever been there. So if anyone has raised a hand has been in the Rockies before, yeah, you know what I'm talking about. So basically it's so difficult to forecast out there, from coming from the plains out to Cheyenne, Wyoming to forecast. It's really a difficult challenge, and I'm going to talk a little bit about that today. But one thing you may not know about us is at Cheyenne, we are one of the offices that are probably one of the busiest offices in the nation with regards to weather in general. We issue the highest amount of high wind products. We lead the nation in pretty much in a lot of the long fuse products during the winter. And with severe weather this year, we've actually been pretty busy too. I think we've issued almost 250 some warnings. So we're right up there with you, Dodge. Yeah.
Thank you.
Sandwich dogs. So we are a very busy office, and this is kind of the reason why we're kind of driving toward this. So our background and motivation, basically, like I said, started about 3 years ago with the University of Wyoming. We basically got into a room at the FO and just started discussing what can we do to improve upon the models. And so, this is really where research and operations really kind of should coexist, is really in the FOs. What are the FOs looking for to help improve the forecast? So we really kind of looked at our area in general, and we looked at how many blowovers we get per year. We get about average 50 blowovers on I-80 just in in Wyoming. So that's quite a few blowovers from wind. We get about 17 road closures, actually about 3 road closures per year, but this is during the statistics 2011 to 2015. There was about 17 road closures, each one averaging about 8 hours. So if you want to try to cross across Wyoming, think twice during the wintertime, because you may not make it. You're going to be stalled right along the interstate with the rest of the semis. So something to think about when you want to cross I-80. We also have averaged about 4, and each one of those, believe it or not, it costs the economy, for every hour that road is closed, about $1 million to the national economy. So that's just something to think about. We have about 4 weather-related fatalities per year. And I was going to show this video, but for the sake of time, I wanted to just kind of give a visual picture of what it's like on a pileup. It is the most scariest thing I've ever seen in my entire life. Seeing people that are just piling up on the interstate. And this happened in 2015. I was just watching the YouTube video of this, and it was just incredible to watch. Some people just videotaping that crash after crash after crash. And this is something that's so scary, and this society doesn't even realize what's going on ahead of us. So that's why we are a partnership with also the WYDOT and the Pathfinder project. All right, so let's look at our winds. All right, so how well does a HRRR do? That's 90 percentile. Well, if you take a look at real statistics, look at our topography. the HRRR does actually pretty decent for the topography we're under. So you can see right there that it's actually picking up on 90th percentile winds. But here's some of our points that we're looking at here. These are all in southeast Wyoming. And as you can see here, the frequency of the probability distribution function, you can see that there's only a few places where it has a higher amount of frequency. One of them being the summit, which is point D, and another one point is Arlington, which is point A. At least that has a higher probability than the rest of these points, which are our gap winds, and they are probably the places where the most blowovers occur. So that's something you got to think about. Are these winds, it may be doing good in high terrain, but it's not doing good at our lower elevations. And some of you in the plains probably realize that, right? All right. Wyoming. Probably the most snowiest place in the U.S. compared to most of the plains. We average about, I think, 30 to 40 days of year of snowfall. Just in Wyoming itself. I think Ethan and Bob can correct me on that. So that's a lot of snow days, but we don't close school for that. And Colorado is also one of those places, as well as Montana. All right, this is the amount of hours. So this is like 30. I should have gone back a slide. That slide represents the annual snowfall, which is about 60 inches per year. And then we got hours of snowfall. That's where we're talking about 30 to 40 days of snowfall. Blowing snow. There's actually no statistics on this, but from WYDOT, they've actually composed some stuff from the HRRR, and they've predicted the amount of blowing snow that exists across Wyoming. And you can see that Wyoming's right in the middle of that, with the heart of amount of blowing snow. Now the northern plains, they also get a lot of that, and it's a little bit more widespread. Ours is more confined, especially in the terrain. All right, another part of our experiment is snow squalls. Everybody knows what snow squalls is this year. Last year, nobody really wanted to, they kind of pushed it away, you know. They didn't really want to issue snow squall warnings. Don't know a little bit much about this stuff, but now it's pretty much in the directive. And here it is. Boy, do they like to write those directives. I was one of those team members, believe it or not. So, oh, what fun that was. So, you know why, how long it took to get the directive to get out. Because there was so much back and forth on that. And Scott, you can probably see, you've seen that. Oh, you're keeping your mouth zipped. I got it. I got it. Okay. Anyway, the visibility with snow squalls, basically, here's the criteria. Quarter-mile visibility or less in snow with road temperatures that are below freezing. That's one definition. Definition 2 is basically when you have a front sweep through the area, and you have the Arctic surge, and you have instability behind that front, and you have blowing snow and flash freezing and all that good stuff. So, condition A allows for instability type snow showers. So that kind of is where we kind of take that into effect. But also, point B is when you have more progressive type snow showers. Does that make sense? All right, and of course, we're probably going to issue these things. Depends on mostly during the day and the evenings. So that's kind of what we're looking at. All right. One of our objectives of our experiment, I've already just killed about 15 minutes of my time. So we're going to try to validate the HRRR forecast, especially for extreme winds, and that's what Ethan Collins is going to be doing. We're also going to be using the HRRR output for real-time prediction, extreme crosswinds and highways. So we're really trying just to validate the winds in the HRRR right now. We're also going to develop some blowing snow products, snow squall products for the HRRR. So we're involved with Trevor Alcott right now, and we're really working hard. They're actually doing most of the work, I should say. We're just kind of the collaborators, but they're trying to work with this and integrate all this blowing snow products, this snow squall products into the HRRR eventually. I'm going to do a fine scale real-time prediction of the blowing snow and snow squalls. Forecasters are going to validate that. And we're going to get to use a specialized computer. And that computer is at the NCAR site there in Cheyenne, Wyoming. And it's run by University of Wyoming and NCAR. And is there other agencies affiliated with that too, Bob?
Off the top of my head, I'm not sure.
Okay, so anyway, that's where we're going to be working with them. Is basically another supercomputer that we can run a 1 kilometer domain. And so we can do that. In fact, if this project continues to, it's kind of a narrow domain right now, covering much Montana and Wyoming and Colorado, but it could be expanded to cover the rest of the U.S. If I'm not mistaken, is that right? So.
Yeah, that's correct.
All right, so we're talking big time stuff here. All right. Now let's look. I'm not going to steal Ethan's thunder here. I know that he's got some plans to talk about this, but here's kind of what the current HRRR forecast is for a 0Z time frame on February 8, 2017. And you'll see a common theme about this, that the HRRR over-predicts winds in basically at wind speeds less than 20 knots. At speeds greater than 20 knots, the winds are under-predicted. So that's something to think about, and that's, I think Ethan has data to support that, so I won't go any farther with that. Ignore the equation. I know some of you don't want to look at equations right now, but this is something that I think is really important to think about. Blowing snow is another part of our project, in addition to the extreme winds. But the blowing snow, we're going to look at what causes the snow to move in the first place. And so we need wind, obviously, to do that. But we also need to get these particles to get moving. So we have to use we use that as a function of snow type, age, history. It's what we call a driftability index. And so we're going to use that to kind of get the value to move and adjust for wind speeds at 5 meters versus where the HRRR predicts at, which is 8 meters. So the HRRR is really not able to predict that 5 meter at a 5 meter level, which is where the blowing snow takes place at typically. But it comes off the ground too. So, but this is something that we're going to continue to work with. Also, visibility is another part of this. We're going to use the snow particle distribution and its variation with height. So that's a really tough thing to grasp right now. We haven't really grasped it. I think Greg Mann tried to grasp that about 10, 15 years ago and try to understand how our particles are moving within a vertical level. And so that's part of the blowing snow that's going to take more than just my brains. It's going to take their brains. So anyway, sort of validation, we're going to rely basically on WIDOT webcam images. We're going to use the GOES R snow cloud discriminator product for validation of blowing snow. That is actually a great product. So think about that. If you write that down, that's a good product to use for both looking at blowing snow. Meteorological observations. We're going to determine where the blowing snow occurs at the current time and it forecast out to 36 hours in advance. We're also going to be looking at the algorithm, building upon the algorithm, and make modifications as necessary. Snow squalls, I'm going to let Bob kind of handle that. He's going to talk about, the various thresholds that the HRRR uses, like there's 2-meter temperatures, there's also the winds. We're going to look at the attenuation of snowfall and the visibility, because I don't think there's any visibility attenuation for blowing snow, but there is for falling snow. So I'll let him discuss that. That's kind of getting beyond my science. So, but then we're going to discuss a little bit about the climatology, where it's going to be mapped on the model, how the model maps it. Then we're going to discuss or have a little bit more about the snow squalls, kind of we're going to be able to predict where snow squalls are going to occur, similar how do we predict thunderstorms. So we're going to have kind of give that ourselves that ability to do that, and so that's kind of one of the main focuses we have. We also are going to use the snow squall parameter by Pete Bonicos. He's the one that developed that in the Northeast. See how it applies for the Rockies, the snow squall parameter, and we're going to validate all this information using our radars, webcams. And if you want to look at snow squalls, another good product to look at is the GOES-R day cloud phase distinction product. Another good product to write down for looking at for snow squalls. All right, there's our snow squall parameter that Pete Bonicos developed. And it basically has to do with the moisture in the lowest 2 kilometers, your low level instability in the lowest 2 kilometers, and your wind. So, but it doesn't take into account frontogenesis or anything like that. All right, let's move on here. This is going to be what our real-time predictions are going to look like after they kind of develop our whole modeling. So this is what they're going to provide for us, University of Wyoming, and what we're going to be using to help as forecasters to validate these events. So this is kind of something for a kind of a zoomable Google map. Here's one for blowing snow. And there you can kind of see the changing colors there. I'm sorry for the color wheel problem there. You may not see that. But you can kind of see there's a little bit of yellow there. And so you can kind of see that on I-25. There's what it's going to look like for blowing snow could be for a very significant blowing snow event. So the yellow might be more of an advisory type. And so, and finally, like I said, we're going to do this high resolution 1 kilometer HRRR. Actually, it's going to be based off the HRRR. And so we're going to be running that at the end of our project. So, here's kind of the timeline. It looks like right now we're going to have blowing snow development, snow squalls, crosswinds develop. We're going to validate all this in the first year, do some web portal testing. So we're going to test that Google map, possibly write a paper. The second year, we're going to start developing that 1 kilometer model, doing the blowing snow squalls, extreme winds. Then the third year, we're going to have the 1 kilometer WRF in real time. So, all right, I think there's our partners. We've got 12 support letters from various people across our forecast area, as well as like YDOT and NDOT. We've got ESRI, we've got 4 forecast offices, we've got all these grad students, we've got 2 PIs, and all from University of Wyoming. And so we've got a lot of support in this project, and we're looking forward to moving forward with it. So, like I said, here's the goals. Blowing snow product in the HRRR, improve the visibility algorithm, including blowing snow, HRRR gust, validation, and web portals and light, and so, and develop a 1 kilometer WRF. So that's pretty much all I got.
We have time for a question or two. If anybody has anything?
Nobody wants to talk about snow.
Nobody wants to talk about snow.
Well, thank you.
All right, thank you.